Yeah, oops. We have 2 times the demand times the setup or ordering cost divided by the holding cost, and we want to take square root. So in this particular problem, we have annual demand is 900. The cost of placing an order is $3, and the holding cost is $1.50 per unit per year. Sometimes, so that's how we're formulating the holding cost right now. It's just $1.50 per unit per year. All right. So we're going to calculate the economic order quantity. So 2 times the demand is 900 times the setup cost, which is $30, and we divide by the holding cost, which is $1.50. So what we get here, we have 2 times 900 times 30 divided by 1.5, and that's 36,000. We take the square root, we get 189.74. Now, there are things in life where you could theoretically buy 189.74 of them. Pounds of wheat germ, gallons of milk. But probably want to round that to 190, and in reality, you might want to just go ahead and round that to 200. But I'm going to use 190. So we have calculated the EOQ, which is all we were really setting out to do at the start. But actually, now that I'm thinking about it, I'm going to go revise this problem. So we're going to calculate the EOQ, and then we're going to figure out what our annual ordering and holding costs would be buying 190 units. We're not considering the cost of the actual things we're buying. That information is not even presented to us at this point. And why are we not considering that? It was because there's no quantity discount. So our purchasing decision about how many to buy at any one time does not affect the costs in any way. So, so all we have to talk about for costs as a function of the order size. This is total costs, and then in parentheses as a function of order size Q. So we'll have the holding cost times the order size Q divided by 2, plus the cost of ordering, so that is S plus times the annual demand divided by the order size Q. So we get holding cost is 1.5 times the order size we're using is 190, and we divide by 2. And then we have a cost of ordering, which is $30, times annual demand, 900 divided by the order size, which is 190. So let's see, we have 190 divided by 2, 95. So on average, we'll have 95 units on hand, times $1.50 per unit is $142.50. And then we have 900 divided by 190, it's 4.73 times 30. That gets us $142 and I guess 11 cents. So if we add those up, $284.61. So as I said in the lecture, when we are at the EOQ, the holding costs and the ordering costs are nearly identical. Now, we rounded slightly. We were using an order size of 190 as opposed to 189.74, and even 189.74 is a slight rounding from the true value. So because we rounded a little bit, the holding costs and the ordering costs are not exactly the same to the penny, but they're very close. They're in the same ballpark. And I want to go back to something here on this part of the calculation. 900 divided by 190. So 900 is the annual demand. Q is the order size. So if you take 900 divided by 190, we get 4.7. So that means we're ordering 4.7 times per year. And obviously, in any given year, you cannot order 4.7 times. Order 4 times, or you order 5 times, but you can't order 4.7 times. So, but that's okay. This equation represents the average cost per year. And so some years we order 4 times, some years we order 5 times. On average, it's 4.7 times per year. So that's all good. There's no reason to take that 900 and divide it by 190 and then round that to some whole number, because that's not what we're going to be doing. We're going to be, on average, buying 4.7 times per year. So there's the EOQ formula. There is the cost for holding and ordering costs when we do not have any quantity discounts. And now the last thing I'm going to do on this particular problem is I'm going to say, well, what would happen to our costs if we decided to go from 190 just to 200, just to make our life simple, because probably things come in packs of 100, and instead of having some poor people have to count out 90 of them, let's just buy 200. It'll save us time on the loading dock. It'll save time for the people sending us the stuff. So why not? So I'm going to do this calculation 2 ways. So one is I have kept this slide and didn't lose it. So our total costs here were 284.61 when we bought 190 units at a time. We're going to calculate the costs when they go to 200 at a time. So let's go here. So the holding cost is $1.50. So $1.50 times the average inventory, which is 200 divided by 2, plus the setup ordering costs will be $30 per unit. And the demand is 900. We're talking about buying 200 at a time. Oops, what's that? So we will have, so we have 200 divided by 2. Gosh, that's 100 times 1.5. Why am I even punching this in my calculator? So the holding cost is 150. And then we have 900 divided by 200, which is obviously 4.5, multiplied by 30, and we get 135. So total costs, 285. Now let's go back and compare that to what we got before, 284.61. So compare that to the answer we got before, $284.61. That's a difference between those two answers of 39 cents. Nobody cares about 39 cents on an annual cost basis. So go ahead and buy 200, knock yourself out. The difference is negligible. There's one other way we could see, so let's see how much that is on a percentage difference. So 284 is the cheapest things could possibly be, because that's what the EOQ was designed for. So if we buy more than that, it's more expensive, right? 39 cents. As some saying goes, you watch the pennies and the dollars take care of themselves. Again, nobody cares about 39 cents. But let's just see on a percentage basis how big an increase that is. So we'll divide the cost of 285. We'll divide that by 284.61. And we get 1.0014. So that means that going from 190 to 200, costs have increased by 0.14%. Now, in the lecture, there's another way we could have estimated that same percentage increase. There's a formula that says, if you're supposed to be ordering a certain amount and you order something else, how much will your costs go up? And the formula looks like this. Take Q divided by Q star plus Q star divided by Q, and see what we get. So we're going to have 1/2 times 2, oops, sorry, that's the cost. Oh, yeah, I could have left the 2. So 200 divided by 190 plus 190 divided by 200. So we have 1/2 times 200 divided by 190 is 1.05. This is very smart. Nowhere near enough. 1/2 times 1.0526 plus, then we have 190 divided by 200, which is going to be 0.95. So that is 1/2 times 2.00266. And then you divide by 2, and we get 1.0013, which is 0.13%. I'm not sure exactly why. I got 13/100ths% when I did it here, and 14/100ths% when I did it here. I must have added something wrong somewhere, or maybe it has to do with the rounding of this cost. I'm not quite sure. But we're talking about, at this point, 1/100th%. So I'm going to say that's pretty close agreement. So going away from the EOQ did increase our costs, but by 39 cents. And like I said, nobody cares about 39 cents. So, so that is how to calculate the EOQ. And maybe I'll just stop there and I'll make a separate video for the next one.